Okay, now here we have another problem dealing with electric current. So please write this problem down. It states an electric current of 83 amps or amperes is branched off into 3 circuits. The second branch carries twice as much as the first. Okay, it's branched off into 3 circuits. The second branch carries twice as much as the first. The third branch carries 5 amps less than the first. Find the amount of current in each branch. Okay, so we're going to find the amount of current. We'll find the amount of current in each branch. Now, an electric current is a flow of electricity. Now, electric current is represented by the variable I. Now, the current is the flow of electrons. That's what electric current is. Okay? So when we talk about this electric current, we can represent it. Let's say this represents the current, and then it's separated into 3 branches. Okay? It goes to 3 circuits. Here's the current, each branch. Okay? Now we're going to, I is the total current. Okay? We also will say equals a total. The total current. So I equals the first branch plus the second branch plus the third branch. Now this is going to be the formula we use to figure out the lengths of all of these. Now here it says the second branch carries twice as much as the first. The third branch carries 5 amps less than the first, but it doesn't tell us how much the first is. So the first is what we mark first. The first branch, we're going to say that's X. We're going to label the first branch as the X. Okay? The first branch is X. Now the second branch, so it carries twice as much as the first. So the second branch is 2X. The third branch carries 5 amps less than the first. So that's X minus 5. 5 less than X. So here we have the first branch represented by X plus 2X plus the third branch, which is X minus 5. Now you have your formula. Okay, now we use our formula. Okay. Now I should be able to erase this now. You should have drawn it already. Now I is the total flow. Now they gave us the total flow, an electric current of 83. So we do know that the total current does equal 83 amps. So instead of I, we're going to write in a value that we know for I, which is 83 amps. I'm omitting the amps or the units until we get done, because we know we're working with all the same units anyway. And I don't want to confuse anyone if you don't know this method yet. But you should always use your explicitly write your units. If I were doing this problem by itself and I wasn't teaching you, I would write amps under each, in its appropriate place after each value. Now we have 83 equals x plus 2x plus x minus 5. It becomes 83 equals, we put all the x's together. We can remove these grouping symbols because that's not an instance of a multiplication here. So we combine all our x's to make 4x minus 5. X minus 5. Now we add 5 to both sides. We gotta add 5 to both sides. We get 88 equals 4x. Okay. Now here we bring the 88, or we bring the 4 under the 88, or divide both sides of the equation by 4. X equals 88 over 4, or if we divide both the numerator and denominator by 2, we get 44 over 2, which is equivalent also to 22. So we know that x is 22. Now x represents the first branch. We know that's 22 amps, which is the first branch. That was our first branch, which is 22 amps. Now the problem asks us to find the amount of current in each branch. So we have to go back to our equation and plug in the value that we know now for x. And then we'll know the value of each. For example, the first branch is x, which is 22 amps. Second branch is 2x, which is 2 times 22, or 44 amps. And then the third branch equals x minus 5, which equals 22 minus 5. Okay, 22 minus 5 is what? That's 17 amps. And so here's our answer to the question. And if you want to check, you want to see, does 22 plus 44 plus 17 actually equal 83? 7 plus 4 plus 2, and 7 plus 6, that gives us 13. Carry our 1, 5 plus 4 plus 1 is 5, plus 2 is 7, plus 1 is 8. It's 83, so it is correct. Have a 270 unit line, okay? A 270 unit line is cut into 3 parts, okay? Cut into 3 parts. The second part is twice as long as the first part. Okay? The third part is 3 times as long as the second part. How long is each part? Now, when you're doing word problems like these, the first thing you want to look for is the information that you're not given. So that's the first thing you have to label, which is your unknown, which is your first part. We'll say is X.